I would say good morning, but I believe it's afternoon where you are.
Yeah, yes, sir. Thank you. But it was the opposite last night when you came to visit us for the tryout, right? For the comms check. So
yes, I'm sure that it was. Let's see. I need to share my screen. So
yes, please. Yes, please.
All right.
And while Darrel, while you launch your presentation, I wanted to say, just for your background information, the students know some GMAT due to the fact that I use it in classes. Let's also define terms for the audience that may not be aware. But with GMAT, you go on to some known territory for them, but except for those who haven't used it yet. So that's kind of your audience right now.
Okay, very good. I'm going to start. Can you see my screen okay now?
Yes, please. Yeah, I cannot see you though, and that we need that too, don't you? Don't we?
Oh, I suppose I can turn my camera.
Thank you. Your call. Your call.
Yes, I don't feel very photogenic, so I often leave it off.
Yeah, well, it's your decision, and I disagree on the photogenic, but it's your decision.
Yeah, so we'll leave it on.
Right.
So I've been involved with the GMAT project since it started, and you will have to excuse me if I fumble a little bit at the keyboard. I'm used to working on Linux, but for presentations, I'm on Windows, and that always keeps me confused.
And in fact, Darrel, as you've seen, we are kind of running it a little bit in an open, informal format, and you are the third speaker today that says exactly that. I work in Linux, and I as an educator, I'm trying to get a little bit into that territory, and at some point I'll ask the three of you, should Linux be taught to students as a matter of course, not as a matter of exception?
That's actually an interesting question. It's a little bit outside of my presentation, but
I throw it out as a provocation more than a question. So, but please go ahead.
I tend to feel like I am about 4 times as fast when I'm working in Linux than when I'm working on Windows or on Macintosh.
You answer the question. Thank you.
And please feel free to interrupt me as we go along. I am hoping to go through slides quickly and get to live demonstrations that we can actually see things. So I'm going to start with just a quick overview, talk a little bit about if you're new to GMAT, how do you get up and running with it, and then talk about some strategies that we use out here when we're supporting customers, and open things up for discussion. So this is basically the timeline for GMAT. We started in 2002 from a list of requirements and a set of goals. And the goals that we started with was we wanted to build an open source, free and open source software tool that was general purpose, that had flexible design, that would run on Windows, Mac, and Linux, and that would meet the evolving needs at Goddard Space Flight Center and in the aerospace community. So that's basically where we started. We had our first public beta release in 2007. We introduced a plugin architecture in 2008 that made it in the next release that came out, which was in 2011. GMAT started being used as non-beta, a production level product in operations in about, with the 2013 release. The first operational release was R2013B. Navigation was added to the system in 2009, meaning orbit determination. So the orbit determination beta was in the 2011 release. It continued to grow into 2014 and entered production in 2016, and it's being used to do orbit determination for a number of different spacecraft at this point. The most recent release was made in 2020, and we have another release that's coming out this October or November. So that's a little bit of the GMAT timeline. We're doing public releases. Right now, we're on a cadence of a public release about every 2 years. I keep pushing my colleagues at NASA to make it more frequent, and they keep pushing back and saying, but we have to have this and this in the next release. So it's kind of a push and tug to get releases out. It has to go through a formal release process at NASA before it can be made public, and that's part of where the hesitancy is in terms of getting more frequent releases. The development focus in GMAT is largely on Goddard Space Flight Center operational needs. This next release is going to be doing support for the geostationary spacecraft. It's basically focusing on the GOES weather satellites. There are a number of other new features that are coming out, including some sensor enhancements, some features that are needed for cislunar space, but the GUI is largely staying the way that it has been for years. Okay. So I'm going to start up GMAT in just a minute, give you a basic system overview, and talk about how users work with GMAT. When we look at GMAT, using GMAT is basically built into, you build two different pieces. You build all of the components that you're going to use for a simulation, you know, a spacecraft and a force model and a propagator and things like that. Those are all referred to as resources in GMAT speak. You also configure what kind of outputs you want. What do I want to see as the mission runs, that kind of thing. And then there's what's referred to as the mission control sequence or the mission sequence, but it's really a timeline of, you know, what order are we going to follow processes as we go through the system. And you'll see all of that in just a minute when I open GMAT up. There are multiple ways to work with GMAT. There's a graphical user interface, which is how most people get started. You can also run it from a console application. You can run it through an application programmer's interface that we introduced with 2020. So you can drive it from Python or from Java. You can drive it from Jupyter notebooks. And like I mentioned earlier, there's also a plugin interface for when you need to add features to the system.
Oh, we want to see Jupyter. We want to see Jupyter.
Yes, I know that that's high on your list.
Thank you. Thank you. Is that just me or?
Yeah, I also no longer have any camera or audio from Darrel.
Okay, but everybody else is here?
Yeah, we're here, sir.
Okay, so we lost Darrel basically, yeah?
Yeah, I think so.
Okay, let me try. Let's see if he comes back in. Can you guys monitor the participants, and I'm gonna send him an email.
Sorry, Fabrizio.
Yeah, we lost the speaker.
Yeah, but
So you just monitor the participants to see if he comes back in, and I will
okay, then.
I will send him an email.
Yeah, he came back.
Okay. Can you please make him co-host then?
Okay. He's already co-host.
Okay. Darrel, you dropped out, but maybe you can.
Yes, my power flickered here.
Yeah. And
Yeah.
yeah, we have the same problem in where I live. So okay, so do you want to start sharing again?
Yes, I guess I'm not sharing now.
Right.
Let's see.
Is that Arizona?
I am broadcasting from Arizona.
Yeah. Okay.
Yeah, I don't know why my power flickered there, but it did, and I can't find my Zoom control panel now. Let's see.
Did you just come back, or did you re-enter the whole activity? The whole event?
I just came back. There we go.
Okay.
Okay, share screen.
Okay. It's coming. There we go. We got it.
Okay.
Is that because I said the word Jupiter that you had the flicker?
Oh, well, don't say it again, then.
Right.
Okay, and no, I did not mean to go from the beginning. Okay, so when I say that GMAT has multiple user interfaces, this is largely what I mean. GMAT is driven from a scripting language, but when people learn GMAT, they're typically starting from a graphical user interface, which is what I'm showing here on the left. So this is what people usually see when they start learning how to use GMAT, is that they'll start up this graphical user interface. It looks a little bit nicer on Windows than it does on the other platforms because the guys at Goddard are largely Windows users. But what's really going on underneath is on the upper right is there's this scripting language that we're running inside of that graphical user interface. And the system was designed so that when you save things from the graphical user interface, it writes a script. When you load configurations, it loads this script, and the script is targeted to look a lot like MATLAB. And then down here on the lower right, you'll see that there's a Jupyter notebook that I will show in just a minute that you can also use to drive GMAT. So let's see. So in terms of, how do I learn the system? Well, the easiest thing to do when you're learning GMAT is it ships with a number of sample missions. Go through the sample missions, work through the tutorials that are in the user's guide. And what I find is that when people do that, it's also helpful if they don't just work through the tutorials, but they try to extend those tutorials and try to do problems that they're interested in. And then once you're fairly familiar with, how does GMAT work, start building some things from scratch. That's what I would recommend in terms of learning the system. And then once you've learned the system, there's some strategies, and I'll show you a few of the things that we use out here for, okay, now I want to use GMAT in a real operational environment. I want to do some mission support, or I want to do design for a mission that I'm trying to propose, or that kind of thing. And I'll show you a little bit about how we work with those things out here. Okay. And I think that puts me to the point. Oh, and then there's also one of the things that I do with a number of different people is I help them figure out how to use this Python interface into GMAT. And they'll come in and say, hey, I need to be able to do this. I want to do it from Python and put it, on my website, or I want to use it in an operational environment where I don't want to have to start up a graphical user interface or that kind of thing. And I'll typically write out lessons in Jupyter notebooks that I then send to people to say, look, this is how you do propagation, or this is how you do coordinate transformations, that kind of thing. And I'll write things up in Jupyter notebooks because I find that's actually a very nice environment to teach people how to use the system. And I hope that you agree with me on that score, Fabrizio.
I think that this is a fantastic plan, and to connect to my students' experience, when you say Jupyter Notebooks, does it mean that there is like a kernel that needs to be installed in Jupyter the way that you would install a kernel for Python, for instance?
They're not, well, let me, so basically we package GMAT with a Python package that you then need to load in through your Jupyter Notebook. I'll show you.
I see. And yeah, I have another question that's been hanging over my head for some time. You say MATLAB quite, you know, as a, you can extend it if you want. You can do, what did you call it? Plugins by means of MATLAB. But is there a reason that if it's doable with MATLAB, it cannot be done with Octave?
So let me show you what GMAT looks like. So if you look in GMAT, you'll notice that, you can tell a little bit about my prejudice because you'll notice that there is no MATLAB link over here, and that's because I don't have MATLAB installed on my notebook.
That is, yeah, and I completely agree.
There is a component of GMAT. It's a shared library that GMAT loads that provides the interface into MATLAB. We've never built that component for Octave. Although people have said from time to time, you know, I'd rather be using Octave than MATLAB, and I completely agree with them. It's just the guys at Goddard have never wanted to fund that because they're all MATLAB users.
And when you say, and then I'm going to let you go again, I'm sorry. When you say that you don't have any MATLAB because it's not your preference, what is your preference?
I prefer to do things through Python.
I see. Got it. Thank you.
And in fact, when I open up the Jupyter Notebook, there are a number of things that I've done in Python that you just can't do in GMAT because it doesn't have those components built. And I just find that a fast environment to get some real analysis done. This is what GMAT looks like when you start it up. I've actually loaded a mission at this point that's called the birthday mission for reasons that will become clear in a moment. This is the GMAT scripting language. You define things like a spacecraft. You define a force model. All of these pieces that you want to use in your simulation, you set up ahead of time at the top of the script. And then there's a keyword that shows up, begin mission sequence. And what that keyword does is it says everything above here is configuration, everything below here is the timeline of events that we want to follow. Okay. So you start up a mission sequence, and what I'm going to be doing in this mission sequence is I'm going to try to go to the moon. And what I want to do to get to the moon is I need somebody to tell me a date. And when we're talking to young kids, we'll say, hey, what's your birthday? And we'll put in their birthday. So that's why this is called the birthday mission. So somebody tell me a date.
I see. Cute.
So I need a date, or I'll use today.
Your birthday.
Oh man, now everyone's going to know when my birthday is.
Okay, well then let's have one of the final project students type in the date that they want. Anyone in the next 5 seconds, not 5 minutes. Can you type a date? Okay, 77. No, but can you do a century from now? They want 7th of July 2099.
Unfortunately, our planetary ephemeris file does not go out that far.
Okay, so something real. something in 2023, guys. Come on. Okay, 29th of June. Is that possible? 2023?
9th June 2023. All right. And if I quit fat fingering my keyboard. So what we're going to do is we're going to launch our spacecraft, the Earth Moon Express, on the 29th of June, 2023 at noon. And we're going to try to figure out how to get our spacecraft to the moon. And so what you'll see is that as GMAT runs, it starts iterating through, trying to find a trajectory that gets us to the moon, and there. We're at the moon now.
Can I ask you a question? When you did that, I mean, typically launching to the moon means deciding orbital inclination and a bunch of stuff having to do with the moon. How did you bypass all that? I mean,
Yeah. So what I'm doing here, so here's the lunar encounter. There's the sun back in the background there, lighting everything up for us. So if I go and look at what the mission is doing, I'm actually doing some targeting here, and I'm varying three things. Let me go back to the script because it's probably easier to read it there. Can you read my text okay?
I can.
Okay, yeah, so what I'm doing is I'm changing the right ascension of the ascending node and the argument of perigee for my spacecraft and the size of the maneuver that I'm going to apply. So basically, I'm moving the orbit around.
Yeah, but the question is this exploration, this targeting that you're talking about, is that is the targeting a function that GMAT offers?
Yes, it is.
Okay.
So what it is we're basically building a Jacobian matrix that's the things that we're varying, these variables, as a function of things we're trying to achieve, our goals. And our goals are, we want to be where the difference in right ascension and the difference in declination between the spacecraft and the moon as viewed from the Earth are 0. That means that we're on the line between the Earth and the moon.
Right.
And we want the distance from the moon to be some distance that we set. Let's see, what did I use? Somewhere here, I say how close I want to be to the moon. And I don't see it right off here. Let's see. Where are you? There we go. So I'm trying to hit dead center at the moon right now. You know, what I would really do if I was trying to go out there and not create a new crater is I would set this value to be some reasonable distance from the moon, like probably 4,000 kilometers or something like that.
And Darrel, this targeting is a script function. It's not a GUI function.
You can set it up either in the GUI or in script. Like I said, anything you do in the GUI gets written to script. But if I come and look at this mission, so this is the targeter. It's a targeter named DC for differential corrector, which is what we call this Jacobian function that lets us solve things. So I'm using that guy. This is what a variable looks like. So I'm starting off with a right ascension of the ascending node of 180 degrees. I'm perturbing it by 1/10 of a degree and using that to try to get to this difference in right ascension and difference in declination. But here's the right ascension of 0. So I can do it through the GUI. I tend to find it easier because I know the scripting language to do it from the script language.
Okay, thank you.
When you're learning the system, it's actually, there are some tools that are built in. Like it's like, I look at this panel and it's like, well, what would my script need to look like for that? Well, there's a button down here that's called Show Script. And what
Yes.
it does is it shows you how you would write that in the script in order to get the same settings as you have on the panel.
But the opposite is not. I understand that not all scripting functions exist in the GUI. Is that correct?
That is correct as of around release 2016 or so.
Mm.
When they started hooking up the orbit determination pieces, Goddard also stepped back from doing as much work in the GUI as they had done previously. So I think that's a little bit of a shame, because what that means is that the system's harder for people to learn with the new features. But
Okay, I see. I see. No, go ahead. No, I don't want to interrupt you. Please go ahead.
okay. So that's basically what GMAT looks like. Now you can use it for things around the Earth. You can use it in deep space to go out to planetary encounters, and so on. Where was I going to go next? Now when I'm working with GMAT, what I tend to do is, like I said, I tend to work on it from the script language, and I also tend to do everything in, if I'm not working in the GUI, then I'll do it in Sublime, which is the text editor that I use, largely because it works the same on every platform.
I see.
So this is a solar sailing script that I've been working with recently. And we're looking at multiple different ways to configure a solar sail in order to go to certain points, and so it's, we want spacecraft where the area to mass ratios are 20, 40, 60, and 80 square meters per kilogram. The way that we tend to do this kind of thing out here is GMAT has in it the ability to include other files that contain script. So my basic spacecraft configuration is an include file, and it looks like this. So it's just your typical GMAT spacecraft. I start at some distance that's about an AU away, and I put on it a ballast tank. I use that to control my area to mass ratio. I just change the mass to get a different ratio. I put a solar sail on it. This solar sail model is actually written as a GMAT plugin that I built out here that lets me steer my sail so that I can accelerate or decelerate. I can set it so that the acceleration from the sail is opposite to my velocity direction. That lets me spiral into the sun, or I can set it so that it's parallel to the velocity so that I can spiral out, and so on. And
sorry if I interrupt, because we are doing solar sails with the students. This is, of course, I understand, because it was too early in the morning when they spoke today, but they spoke for about an hour only about solar sail thesis projects that they are doing. So they would love to learn the kind of scripting that you're doing right now. And I'm wondering if this is part of a thing that you will share, or if it is proprietary at this time. I mean, is this something that we could look at?
That's an interesting question. I've been treating it as proprietary. Let's talk offline. And
yeah, of course. A subset would already be helpful. Thank you so much. If
yeah, I mean, it's let me see.
No pressure, just the solar sail features the way that we know them are a little less clearly documented. I mean, we have seen those what is it called? Sorry, there is a file that defines a polynomial file.
Yeah, the SPAD file.
Yeah,
Yes.
yeah. And that is not really user friendly. And I was trying to find a way to teach it a little more effectively. And now I see that you are basically freely typing away. And so maybe there is a better way.
What I find is that with the guys at Goddard are not doing mission support for anyone that's doing solar sails. So I haven't thought about, well, how do I do that? But one of my outside contracts is looking seriously at solar sailing. And so it's like, okay, I need to build some models so that we can do what they need, but GMAT doesn't have them. And so I built this as a plugin.
Ah, I see.
So it's basically a shared library that loads in order to let me do some sailing.
Yeah, and that is clearly, well, hey, at least I'm happy that we identified a possible area of improvement, because clearly what you have done is what was necessary to be done.
Yeah, and that's typically the work model out here is I spend about 2/3 of my time doing support for GMAT for Goddard, and then the other third I'm trying to support other people in the aerospace industry that are using GMAT or need to extend GMAT or run GMAT from Python or things like that, where you can't pick up the GMAT documentation and just read it and know what to do.
Yeah, it's and I like manuals. I'm the kind of guy that reads manuals, but that one is another thing. It's right. Not, yeah.
Well, I mean, GMAT is a big, complicated system, and for someone like me who's been working with the system for 20 years, it's like obvious how everything works. But that's not true for anyone else in the world, it seems like,
Yeah. No, I mean, what I appreciate the fact that there is such an abundant literature, because sometimes in free open source, what's missing is exactly the support information. You have it. It's upon us to study it, but in the case of sales in particular, I was a little bit encountering a difficulty in implementing a mission in which, particularly if the sail is realistic and it slews at different angles, that kind of thing.
Right. Well, I'm glad this is the sample that I opened up for you then.
Yeah, absolutely.
Because the other example I'm part of, there's this group with the AIAA called Practical Interplanetary Propulsion. And one of the pieces of work that I've been doing with them is figuring out, well, if we have a nuclear propulsion system, let me see, where is it? There we go. That can give us very, very high ISPs. That's good. Of course. As soon as I tried to open something that's, I opened the wrong one. That's why. So you'll notice that I just opened a script that's the actual pip script. Pip is practical interplanetary propulsion. So it's a pip script, but this folder is my Linux path, and so it couldn't find things. So
yeah.
File. So it can't include file. So it highlights the line where there was an error. It's like, okay, yeah, I know right away what I did wrong.
Yeah. That's happened. Sometimes that happens to us. If I email the students a GMAT script and it lands into their computer, when they open it and the file structure is not the same, then they're gonna get a message like that, right?
Yeah. So one of the propulsion systems we've looked at is what happens if we do a fairly lightweight spacecraft, but for our thruster, we put on it a linear accelerator. And so we're shooting an ion beam out the back of the spacecraft that's going at a reasonable fraction of the speed of light. That gives it very high ISPs. And it turns out that if we do that, we can fly a mission that looks like this. Okay, so we're starting down here. We orbit the Earth for a little while. We come out, we do a flyby of Saturn, and we use Saturn to change the plane of the trajectory out of the plane of the ecliptic so that we can go to the solar gravity lens point down here.
Mm-hmm.
So this gets us to a point that's about 550 AU away from the sun, and it gets us there in about 10 years. If we can build this thruster. And so this is the kind of study that we would do is, we look at this kind of thing, but we're doing it with a spacecraft where we want to look at many different configurations. And so that's why we do this with these include files where we set all of the common data in include files, and then we write separate scripts for each configuration we need to look at. That allows us to make sure that we have consistent configurations on different boxes, different platforms across the system. And so that piece we find to be very useful, to be able to do all of this stuff using include files and then adding the configuration for the specific piece that we're studying in the main script. And does that make sense?
Yes. Well, what I am understanding, I'm kind of processing all this, but frankly, I think also that for the students and in part for me, it is interesting to see that we have free open source that we've been discussing today. And although the software is free, there is a huge marketplace around it that is enabled by the free open source software. In other words, you can get a job doing FOSS, which is something that many people do not appreciate fully. Am I understanding correctly the market, the business plan?
That's right. I mean, if you looked at the commercial offerings that do the kinds of things that GMAT does, you're typically talking $100,000 per seat. When customers don't have that price tag where they have to buy a license for Satellite Toolkit or for FreeFly or for one of those other tools, that frees up their budget to talk to people about, can you help us solve our problems instead of help us buy the software so that we can go solve the problem?
Yeah. Great. Thank you so much.
And so that's kind of the market that I'm in, is helping people solve problems using these tools that are out there for free.
Yeah, well, that's very interesting, so that people understand that there is value in a free tool, which is not clear to some people,
Yep. So there's one other piece that I promised I was going to show, so I better do it. So I'm going to go start Jupyter.
Yes. Thank you.
All right, so I'm usually working in Jupyter Lab on Linux, and on this laptop I have Jupyter Notebook installed instead of Jupyter Lab, so I might fumble around a little bit, but hopefully not too much. And what will I do? Let me do this one. So this is an example of one of these pieces where I was showing people how to do propagation using GMAT inside of their API.
Mm-hmm.
And so, and I probably haven't proofread this to be sure that my English is good and that kind of thing.
No problem.
I typically will find that no matter how many times I read it, I'll have misspelled it.
Yeah,
I'll have misspellings. I'll have TEH instead of THE and things like that.
I'm familiar. No problem. Yeah.
So I'll just step through this guy. But basically, there's a file that I use. It's called load GMAT.
Mm-hmm.
And go ahead and open that one. I think I can open it here. Yeah. So this is my load GMAT file. What it does, and this file actually ships with GMAT 2020.
It does. Oh, okay.
There's a folder that's at the same level as the bin folder named API.
Okay.
This folder sits in there, and what you have to do is you have to change a string called GMAT install to be the path to where the top level GMAT folder is.
Okay.
And so for me, it's on this machine, it's in GMAT R2020A.
Okay.
So you run that, and there's also a Python script in there that goes and creates a file named API startup file, which is like the GMAT startup file, but it has full path information in it, so you can run it from anywhere, instead of having to run inside of the GMAT folder structure. Okay, so with those two edits, okay. The home page there, that's what I wanted. So what I'm going to do is I'm going to load that file, and I try to fix this every time I see it, because I used to import everything from that file, but instead all I need to import is GMAT, which is a little bit more kosher when you're working with the GMAT, when you're working with Python. You know, it's you typically in Python, people frown on importing star.
Okay, got it.
So anyway, let's see. So as I run through this, so I'm going to configure. So if I want to do propagation, and I want to use GMAT for it, I want to propagate a spacecraft. So I start by building a spacecraft. And the way you do that through the API is you sit. So the construct command in the API is like the create command in the GMAT script. So what I want to do is I'm going to construct a spacecraft, and I give it the name LeoSat. And then I'm going to go and I'll set it so that it's has a semi-major axis of 7,005 kilometers with, fairly circular, 28.5 degrees. That sounds like I launched from Florida or something, and I'll give it a dry mass of 50 kilograms and some smallish areas, just so that I have something to work from.
And these and the instructions that follow construct, are those script instructions?
So if I had written this in script, the scripting would have said leosat.date format equals UTC Gregorian.
I see.
And so on. So there's a one-to-one. So set field in the API is like the script line where you're setting fields on an object, on a spacecraft, or on.
I see.
So on. Okay. So let's see, did I run that one? I don't remember, so I'll run it again just in case. And then I want to configure a force model. Now, another thing that's built into the API is it has a help function. So I'm going to go ahead and build a force model, and then I'm going to call its help function to see what that force model looks like. And what I see is that, hey, I've got a central body of the Earth. I don't have any gravity fields set up. There are no point masses. There are no primary bodies. There's no polyhedra or anything. Drag's turned off, SRP's turned off. If I propagate with this, I'm going to go in a straight line.
Yeah.
So then what I need to do is I need to start adding forces. So I'll go and I'll configure a gravity field for the Earth. So this is the configuration. I'm doing an 8x8 gravity field. I'm using the JGM model, and I'm going to add that gravity field to the force model that I'm going to be propagating with. Okay. And I went ahead and added sun and moon, because if I'm orbiting the Earth, I almost always want to have sun and moon turned on. I'm going to turn on some drag. I'm going to make it Jakia Roberts drag. I don't think I turned on SRP in this model. Yeah, so it looks like I'm just doing the sun and moon point mass and then a drag model. And then when I call the help function on the force model, I can see that those things have been turned on. I now have a primary body of the Earth. I've got the sun and moon turned on. I've got Jakia Roberts drag turned on, and so on. Okay, does that all make sense?
The syntax of these cells that we're looking at, is that explained somewhere in the GMAT support literature?
Yeah, so in that docs folder, there is a GMAT API users guide.
Okay, good. That's it. Okay.
And that's now, the API right now is considered a beta product. And the reason, there are two reasons for that. One is that in our 2020, it was not, it had not been rigorously tested the way that we test things that are going to be used operationally. And it was pretty new, and you know, I wrote the document, but it hasn't really been scrubbed.
Okay. Okay. But I'm sure that it's irreplaceable help. So thank you for that.
Well, but it's also a, you know, if you get confused, let me know what's confusing so we can fix it.
Of course, I will be very happy to be a guinea pig for you. No problem.
Yeah, and I'm happy to answer questions about it too.
Thank you. Thank you.
So anyway, so we can keep going, but let me just, we're running a little bit short on time, and I know that Ravi is just chomping at the bit to talk.
He is.
So I can also go in, I can query any one of these forces that I set up. I said, oh, how did I set up my Earth gravity model? Oh, it's 8 by 8, and so on. I can also, from inside of the API, if I decide I wanted to go back to GMAT and build this into a script, I can get the GMAT script from the API.
I see.
And so I'm just going to go ahead and run the full notebook now, rather than keep boring people by stepping through everything.
No, yeah, surely not boring anyone, but thank you.
But yeah, so you can go along and you know, you configure an integrator, and then you hook everything together. You know, the integrator needs to know what force model it's using, and so on. And this actually mimics pretty closely the way that GMAT scripting works, but you can do all of this from Python or from Jupyter. And you'll see that at the end, I can show that I actually did propagate, because I can build position and velocity graphs.
And these graphs are Python instructions at this point?
Yes, so I'm using, oh, what's the package called? Yes, I'm using matplotlib.
Okay, yeah, I mean, no, the reason I was asking is that since it's confession time, I'm more of a Mathematica guy, so I would like to switch out of Python into the Mathematica kernel, because now that is free. And so I can create these same graphs by using that, you know, that's what I'm saying. And so that's, this is very exciting. I am so happy to see these developments. I mean, this is like Christmas. Wow. So thank you so much, Darrel. And I will follow up with the document, with the Jupyter and the API manual, and I will also write to you regarding the solar sail, whatever it is that you feel like sharing at the pedagogical level, basically. I'm not asking for anything proprietary if that's a problem. But if it is a problem, just say no. I can take no, so no problem.
Okay. And so just one last piece. So I talked about how there's this plugin system that GMAT supports.
Yes.
Ravi actually uses it for what he's going to show you next. But you can go so far as to plug in things like an entire front end to GMAT, which is what you're looking at here. This is Astrodynamics Workbench. It's the tool that I use on Linux for support. And what I find is that the GMAT GUI it takes up a lot of screen real estate that I don't want to give up when I'm trying to see things. And so this is a set of asteroids that are near the Earth. This is what they look like when you look at them up on the sky.
Wow. This is coming from Astrodynamics Workbench.
That's right. This is an early version of Astrodynamics Workbench that I'm showing here.
Yeah.
And you know, it lets me do things like that's not what I wanted to do. So it lets me, here I'm doing this include file.
Mm-hmm.
I can go and open that include file from inside a Workbench, and which is something that's a little bit more difficult to do in GMAT because they don't really provide, the GUI is older than the include files, basically.
I see.
So, okay. Well, that's everything I had to show you guys.
I think that we probably could keep you another 6 hours asking questions, but we need to limit. I was told to not go into the next day, so I am very impressed by all this, and I mean, really, GMAT is one of those things that I see students excited when they use it. So I'm very happy that we are at this point with GMAT, and I would also have questions about navigation and all the operational side, but we need to keep something for when you come here to Izmir to visit us, Darrel.
Well,
okay?
I'm looking forward to that trip.
Okay, so that's what we're gonna do. We're gonna talk about that when you finally come to beautiful Izmir.
Okay.
Thank you so much. And so we thank Dr. Conway for his contribution and all the materials and guidance on GMAT that we use in our classes. In case in case they haven't been in my classes, now they know what's coming.
Well, and I appreciate the invitation to talk to you guys.
Thank you so much. I really appreciate that. And we'll take a 5-minute intermission until the next speaker starts. And we thank you again, Darrel. Thank you for coming.